Elon Musk's mission with Tesla is no secret. Accelerate the world's transition into sustainable energy by making his electric vehicles super affordable. To do that, the Gigafactory will have to produce 500,000 cars a year, and for that, he is going to need an incredibly efficient production chain and a factory the size of a few football fields at least. Tesla currently has 4 Gigafactories around the world. The Nevada base, which is 1.9 million square feet and still only 30% complete, the New York base, which is focused on solar energy more than vehicles, Shanghai, which is the newest one and handles the final assembly of the Model 3 and production of the Model Y, and the Berlin base, which is still not operational but will be soon. The Tesla Gigafactory was made for the purpose of upping production to help drive down costs, and efficiency is everything in this game. So today, we're going to look at how Tesla cars are made in these giant factories. Welcome back to our channel. If you haven't already, make sure you hit that subscribe button and ring the bell so you never miss a video from us. There's no doubt that Tesla's assembly line is the best in the world, and it is supported by hundreds of robots and thousands of human workers. The Gigafactories have 160 robots, which, by the way, are all named after X-Men characters. Many of the Model S's unique components, including the battery packs, modules, and drive units, are manufactured in-house. The plant has a high level of integration compared with other modern car assembly plants, so most processes take place right here. This includes most of the stamping and machining, painting, and also some coding. Even the design engineers work in the factory itself rather than in a separate facility. But let's start from the start, shall we? There are few components made from raw materials in a typical auto plant, which has been the case since 2016. Around 60% of the car's parts are sourced from North America, while the remaining is sourced from Japan. The Tesla Model S starts with a coil of raw aluminum, which is cut, stamped, and joined to create a complete vehicle, all within one facility. It starts with uncoiling the coils in a blanking machine that flattens the metal and cuts it into fat pieces called blanks, and additional cutting is done by lasers. The total weight at this stage comes to only 410 pounds. A robot then transfers these blanks to the tandem press lines, where the sheets are stamped into the various panels of the cars. The Schuler SMG hydraulic stamping press line is the largest in North America and the 6th largest in the world, and uses up to 11,000 ton force to form the body panels. The upper section applies 1,400 tons of downward force and the lower section 113 tons. The blank aluminum sheet is stretched over the lower draw die, and the openings are cut, with robots transferring the panels between processes. This is all carried out by giant robots, whirring constantly. The humans come in around this time to inspect every single panel and ensure correct pressing. The parts are then all stacked in frames and stored. The machines press one part every 6 seconds and create 5,000 parts per day. Meanwhile, the batteries are being manufactured in a different place in the Gigafactory altogether. The battery for the Model S contains 7,104 18650 lithium-ion battery cells, placed in 16 modules. Each module contains 6 groups of 74 cells wired in parallel and wired in series within the module. Unlike every other electric car manufacturer using specialized large-format lithium-ion cells, Teslas use commodity cells, which are commonly found in laptops and phones. Their liquid-cooled battery pack uses an intumescent gel to help in fireproofing and even in distribution of heat. And no, we aren't even close to the assembly stage yet. We haven't even discussed the motors. The alternating current induction motor is constructed in-house, and it begins when a robot unwinds over half a mile of copper wire per motor. It then pulls the wire into a stack. Since a Tesla motor has 3 phases, it requires 3 coils of copper. A worker will then lengthen and straighten each bundle of wire. Each bundle is insulated in a plastic sleeve to prevent them from touching one another, and the ends are snipped to the correct length. Then, lugs are added and crimped to form attachment points for the motor's 3 phases. A specialized sewing machine then binds the coils together, and the increased tightness increases the efficiency of the engine. The main components of the motor are the stator and rotor. At this stage, the stator is encased in a two-part epoxy resin to help evenly distribute the motor's heat. The stator is now complete and inserted into a heated metal case and left to cool. The worker uses a hoisting system to insert the rotor in the stator, thus completing the construction of the Tesla motor. Coming to other drive unit components, the worker installs the differential and other sections of the gearbox and attaches them using bolts. Then the tests begin. An air leak test, for starters, to check for any microscopic holes, failed seals, and other defects that could cause issues in the long run. After that, a three-phase tri-pole power inverter is installed on top of the motor to convert direct current from the battery to the alternating current for the motor's use. The power inverter is made from metal oxide semiconductor, or MOS, power transistors. Then the motor undergoes a few more tests to ensure proper functioning before being moved to the general assembly area, where it meets the body and the battery. The body of the car is raised, and the drive unit is installed into the rear axle assembly. This unit sends power directly to the wheels without a drive shaft. After that, the battery pack, which weighs almost 1,200 pounds, is raised into the car using a lift. Batteries in Tesla cars sit at the base of the vehicle to offer strength and lower chances of the car toppling over in an accident. Then, a titanium plate is put out over the battery pack, which protects it in a high-speed collision and from road debris. At any typical automotive plant of any other brand, the car is essentially on a train that never stops as components keep getting added to it. In the Tesla Gigafactory, however, the Model S is on a smart car, which moves around the plant as required. Workers stop the smart car to inspect different elements throughout the process. Tesla's 160 robots work alongside 3,000 human workers, and they all have very specific jobs. Sometimes, however, a robot can carry out different tasks by switching its tooling. After just 13 years in the game, that kind of innovation proves Tesla is running full speed ahead, and there's no telling what their impact will be in 20 or 50 years. Tesla is also making its 5th Gigafactory in Texas, and according to Musk, it will be an ecological paradise. The site sits on 2,500 acres of land, and the goal of the factory is to produce Model 3 and Model Y cars for easier distribution in Eastern America. It's also going to be the main factory for the highly anticipated Tesla Cybertruck and the Tesla Semi. Some larger buildings have already gone up on the campus, and Tesla is even posting job opportunities for the site. It is also rumored that there will be a Gigafactory in Asia outside of China, another one in the United Kingdom, and one in India. These are all unconfirmed, but if Tesla continues at the rate they're going, we might well need those many Gigafactories to meet demands. All in all, Tesla is continuing to expand its global footprint with hopes to provide the world with affordable electric cars, solar panels, and clean energy. If you're planning to do your bit for the environment and switch to EVs, make sure you order them now though. At the moment, production isn't at the scale of legacy car makers, and each Tesla car is made to order, which means it's a 2 to 3 month wait for delivery, even if the actual assembly process takes no more than 5 days. So, would you ever buy a Tesla? Let us know in the comments below. If you enjoyed the video, make sure you hit the like button and check out the Simply Tech channel for more. Thanks for watching, and we'll see you next time.